Looks like we have a gentleman who turned his air conditioning on yesterday evening as the temperature went up a little bit. Said after about 30 minutes he did not really notice any big change. He looked at his thermostat and it had actually gone up a degree in the house. He stopped by one of the vents he could reach, held his hand up and couldn't really feel any cool air blowing out. He did feel airflow, so he walked around outside and said the heat pump was not running on the outside of the house. So we'll stop by and take a look and see what we can get into. So we know from the thermostat confirming that it is calling for cooling on our yellow wire here. It's attached to blue pink, but our contactor is not pulled in. So if we go back up here, we can confirm there's our blue pink, runs through our high pressure switch on this particular unit, I believe. So we should see 24 volts between our common and our blue pink. And that confirms that we are running. The other pressure switch would be yellow pink, so that's our low pressure switch. So we should not see 24 volts there, because if we do, that means there's a break in the line. So we do see 24 volts there. So our low pressure switch is tripped. After attaching our gauges, we do see that we've only got about 5 pounds of pressure. So we are indeed low on refrigerant. So we'll start looking for a leak somewhere. Yeah, right there. Bottom of our accumulator is leaking. What can happen with those guys is if it's painted, there's also a nut that is, or a bolt rather, that is welded to the bottom of these. And as they get screwed in, they'll sit in whatever sludge may be in the bottom. And eventually, because it's heated up so much, there's not really a good paint seal on the bottom of them, or when they twist them in, when they tighten them, it busts the paint, and the bottom of those sometimes rust out. But right away, just from pulling the cover, we see this band running across here. Don't know if it comes out well in the camera, but that is oil creep coming back up. We do have some rusting, and inside the pan itself, you can kind of see that shiny residue. That is oil in the pan. If we listen really closely, you can actually hear it leaking somewhere back in the back.
This striker bead.
So when you're doing this and it still has any refrigerants in it, like where it's boiling off, you do your best to evacuate it, but there's always going to be a little oil that's still giving up down there. But this particular one's been empty for a while, so that was just nitrogen that was coming out with a little poof of oil. But be sure to keep your head away from it, just because you can get a fireball. She is. Just in case you were curious, that's what I was getting. Is that where that bolt goes in right there? Mm-hmm. It rusts out and you'll get a leak down on the bottom of it. Little rubber guys in there. You can grab it with your pliers and pull them loose. But usually there'll be a nitrogen holding charge.
So what you're saying is aim it at you and pull
Yeah,
it?
Yeah. It's not much pressure, just enough to make sure moisture doesn't get in. Poof. We'll bend it slightly, that way it pushes itself in.
How's it going, guys? My name's Jacob. I'm an apprentice, and Jared went to go grab the drill and turn the nitrogen on. I'm taking the doors off so we can take this coil out and put our replacement in. But I'm having to do it with the nut driver because Viking Man forgot the freaking drill. Can't let Viking Man do anything, you know? This is our liquid line. Oh, there went the piston. You see this little guy right here? It's a piston orifice. It goes right up in here. Scratch here. Get out of my way. Move it up. Move it up. 3 stories of floor.
There you go. Beautiful.
I think I've never. Oh, you got more. Did you turn the nitrogen?
Yes, nitrogen is on.
Oh, I feel it.
Yeah.
Wow. Probably the 3rd or 4th.
So you notice there's probably a problem there.
Yeah, there is a problem. They're the same size, so we need a little piece to go in between.
Look in my bag. I also happen to know where there's some pipe the exact size.
Where does that be? Oh, what a smart feller. Beautiful. Uh-huh. Uh-huh. Uh-huh.
That's where your flames going. Now it'll be a little easier because it's already trimmed with the silver where you under it. Just ready to roll.
Pretty close, if I did get it. I think I got it.
We'll know in a moment. You might also want to torque that a little bit so that it springs in instead of back at you when you heat it out. Or you're going to pinch it down.
Talking about this?
Yeah.
All right.
There you go. We'll let you get your drain hooked all back up and the rest of it buttoned up, and I'll go put a pressure test on it.
Hi, Captain.
Swapping over from our low flow regulator. Lower 100. Once again, we don't see any bubbles anywhere. So we'll go outside, check our pressure, and make sure it's holding. And we'll let Jacob finish up in here and get the vacuum going. We'll purge our nitrogen back out. Just putting everything back. Black wire, L1 through the relay. Purple wire is our common, and I believe they had it attached to the capacitor common. Brown wire is capacitor. For start windings for the motor. Being that our vacuum is still holding, we are going to start by adding refrigerant to the nameplate value, as saying, I believe it was 9 pounds, 12 ounces. We won't quite hit 9 pounds because we changed from a piston to an expansion valve. So we'll get up to 9 pounds, and then we'll watch how the TXV reacts and then decide whether we need to adjust it or add a little more refrigerant, or if it's just right. So we'll call it here. Give it a few minutes to equalize. Don't want to slug that compressor. Plug her in. We are that good.
You are that good. I'm apprenticing, so I'm not that good.
I believe the charging chart on this one, being that we did change it to an expansion valve, I think it's calling for 7 to 9. Subcooling. Yeah. All right, I think we've got this one wrapped up. Good job, Jacob. Unhook us. There you go.
All right, I got this.
Got this turned off.
Double check. Yeah. Now,
open our manifold. There we go. Pull it all through till it drops down about equal. Perfect.
Yeah.
I'll say we're done, sir. That one was pretty straightforward. The thermostat was calling for cooling, checking the outdoor unit. We did have 24 volts on the Y wire going between the high pressure switch in the unit. We still had our 24 volts, but then checking through the low pressure switch, it was definitely tripped. Checking the refrigerant, did have low pressure. After a little bit of searching around, we did find that the accumulator was leaking. They are somewhat prone to doing that. If the bottom of the unit gets filled up full of sludge, there is a bolt or threaded rod welded to the bottom of those guys usually, and as they're screwed down on the bottom, it's a spot where they can rust. Either they twist them too tight, or the paint doesn't seal real well right there, or what have you, and they can leak there eventually. So did find that leak. Going upstairs, we immediately heard the leak, so didn't really have to go anywhere else with it. But you also saw the oil pattern where it was creeping back up that galvanized steel, and we saw a good example of what electrolysis and formic corrosion can do to the galvanized plating that holds the coil in place. Where it's rusting there. The rust wasn't actually the coil itself, it was just the galvanized sheet holding it together, but it can be an indication you might have problems. We also saw the oil in the pan itself. We went ahead and used the leak detector, but you saw how little it was actually going off. But being that we could hear it, the prognosis was pretty easy. But that is a good example of, yes, all our fancy tools are helpful, but just because it doesn't go off or doesn't go off much doesn't necessarily mean there's not a leak. It just means it's not picking it up correctly for one reason or another. So don't trust your leak detectors 100%. Use your other senses, your eyes and your ears, to see if you find a leak. But we'll give him a price on replacement of that coil and accumulator on the outside. However, being that thing is somewhere around what it was manufactured in 2012, it does have a few years on it, so we'll also give him an option to replace that unit. See which way he feels like he wants to go with it. Me personally, as old as it is, as many problems as it's had, leaking oil equals problems for the compressor, overheating compressor, probably not long for the world. If it were me, I would go towards more of a unit replacement, but we'll leave that up to him. And depending on which way he wants to go, we'll either do a check back up and replace a coil and an accumulator, or we'll pass it over to the installation crew and let them take over. But it's on to the next one now.